welcome to our channel Just Genius. In the last video we have discussed about introduction to the big omega notation. In this video we are going to solve a problem related to the big omega notation. So before going to solve this problem, I recommend you to watch the problem related to big O notation, because this problem is similar to the as we solved in the big O notation. So please watch that video once again. So let us start this problem. Let us solve this problem. So so this problem is given based on the big omega notation. So if you have to recall some points related to big omega notation, that is one point big omega notation is used in lower bound conditions and it is used in best case scenarios, and also you have to remember a identity, that is a condition, that is f of n greater than or equal to c into g of n. Okay, you have to remember this point, and along with this you have to remember this one. We know that f of n equals to big O of g of n from the definition of the big omega notation. Okay, so by using this condition we will solve this problem. So answer is given big omega of n. So let us solve this problem. So I hope that you can able to see the screen. So when you look into this, f of n is given as f of n equal to 3n plus 2. F of n is given 3n plus 2. Okay, so we know that according to big omega notation, f of n greater than or equal to c into g of n. So g of n equals to n. So why g of n equals to n? I already explained in big O notation. So f of n is a linear equation. So the power of this linear equation is 1. So g of n becomes the n, because the highest degree power in the f of n equal to g of n. Okay, so let us solve according to this condition this problem. Okay, 3n plus 2 greater than or equal to c into n. So if I substitute c equal to 1, this one becomes 3n plus 2 greater than or equal to n. So also if I substitute n equal to 1, so in the left hand side I get 5, in the right hand side I will get 1. So this condition becomes true. 5 always greater than 1. So not equal to 1, 5 always greater than 1. Five always greater than 1. So this condition gets true. So if this condition gets true, we know that f of n equals to big omega of g of n. So what is the value of g of n? That is n. So hence we got the answer equal to n, big omega of g of n. So g of n equal to n. So g of n equal to n. Hence answer is big omega of n. So once again you can check this, how to solve this problem. It is very easy. So once if you substitute here, if you come to here, so this value becomes always n greater than or equal to n naught. Here n naught is 1, n greater than 1. So you have to substitute value greater than 1 in the place of n. If you substitute value less than 1 in the place of n, this condition gets false. So maybe if you get substitute n equal to 0, it condition gets true. If you substitute n equal to -1, like that, it conditions get sometimes false. Okay, with this we have completed this problem related to big omega notation. So once again, if you don't know, once again watch this video. Watch this video. Okay, the each and every material of these data structures and algorithms can be uploaded in the description box. You can access that link from the description box. So before going to this, I will explain this one thing in this slide. So I have explained your performance clarification, means I have explained an order, that is 1 less than, n less than, log n less than, root n less than. So like this I have explained a performance order to you. So when you recall that performance order, so I will write that performance order now. So don't fear. So why I am going to write this performance order, you already know, because we have solved this one related to this in big O notation. So once again observe this one. 1 less than, log n less than, root n less than, n less than, n log n less than, n square less than, n cube less than, dot dot dot, so on, 2 power n less than, 3 power n less than, dot dot dot, n power n. So if you remember this performance order, so 1 root n log n up to here, this is called lower bound conditions, means LB. Lower bound means LB. So this n is average bound, AB. So all of this one are upper bound. Okay, so why I thought this order? So once again, if you see here, we got answer big omega of n. In the place of n, you can write root n, because so once again, if you look into this order, so until n these three are four are lower bound conditions, because lower bound means big omega notation is used in lower bound conditions. You can write any value in the place of n. So I wrote root n in the place of n, so answer is correct. So you cannot write answer like big omega of n square. So this is wrong, big omega of n square. This is wrong because n square value is used in big O notation, whereas in the big omega notation is used in lower bound conditions, whereas in big O notation it is used in upper bound conditions. You cannot write in the place of n square value. If you get answer n, you can write any value 1 or log n or root n or n in the place of n, in the place of answer you got in big omega notation, whereas in big O notation you can write any value related in the upper bound conditions. Okay, what you have got answer. Okay, so this is why I have taught this order. Remember this order very carefully. This is useful in time complexity. So with this we have completed this big omega notation. Okay, thank you.